My name's Chris Baker. I'm CEO of iPSNP Computing. I'm also a professor at the University of New Brunswick in Canada. Basically, iPSNP was established in 2011 to commercialize a technology for data federation. Effectively, it was a rough diamond that we were able to polish. It's essentially a solution for integrating online data, enterprise data. We've taken on challenges in fintech, biomed, and agri-informatics. We do some consulting. The product itself is a self-service data federation technology for real-time access to data for ad hoc queries to live data from distributed locations. Okay, so in general, we have the product customer scope for us is B2B licenses for the query engine to coordinate access to a wide range of online web services. And our key product is a query engine and a visual query interface, which is also available through OEM licensing. Our customers are typically people who are government agencies, people in private equity analytics, hospitals in the US, and we have an emerging client base in the UK. Okay, so what are we actually doing? Right. So I'm going to go through a few simple use cases here. So in the context of hospital-acquired infections, the challenge is that in order to be able to diagnose a patient with sepsis, you need to be able to access data that's in different databases around the hospital enterprise. Just being able to pull out diagnostic variables then need to get fed into an algorithm that then be able to predict very quickly in real time that a patient is at risk. If you get to the patient 12 hours too late, the chances of their survival are very slim. Unfortunately, 50% of people who die in hospitals in the US right now typically die from late-stage sepsis. So surveillance, this is essentially surveillance technology using data federation, clear use case of data federation. We've also been able to leverage the same technology to be able to do advanced classification in an academic context of fat molecules. Eicosapentaenoic acids have been curated automatically and compared with manually curated databases, and done that very efficiently using these approaches where the classification algorithms and the annotation algorithms are in different locations. So the point there being that we're not just focusing on data, access to distributed data, we're also leveraging algorithms that are in different locations. Okay, so we also do annotation of microarray gene chips. Also, this is a very important domain because these annotations go out of date very, very rapidly. So Cedi services have been very crucial for that. We've also, next slide. Okay, we've also been leveraging Cedi with text mining algorithms. So we're able to delegate tasks to remote tasks to mine genomic annotations directly from the literature, looking at the impact of these mutations on various diseases. Moreover, also helping people in governments decide what the pollution limits should be for compounds that are emerging from mining processes, so being able to inform policy. In the agri space, we started collaborations with a UK charity who are based in Kenya, and they have an app that they give to farmers, which is multilingual. It's in English and in Swahili. Of course, they want to have access to data that is maybe already pre-prepared, but also they need access to information that is computed in real time, and I'll show a demo of this. Okay, so the key here then is that federation of data is pulling data from distributed resources. We want to have access to query thousands of databases as if there were one. We want to have more agility than just these large warehousing approaches. We want to be doing just-in-time algorithm execution, easy addition of new sources into a framework, and live data querying. And we really want to be able to make declarative statements of what we want. We don't really want to have to program workflow scripts. So this is the Cedi Framework that is initially developed in 2009 in the University of British Columbia. So in this basic framework, you have a query engine, so an end user who interfaces with a query engine. The query engine basically has to need some lookups. It needs to be able to go and find where web services are on the web, and it does these because they are semantically annotated, and they're semantically annotated in a specific way according to the Cedi design patterns. So all the distributed resources then are available, have a description that is put into the registry, and that is essentially the medium by which you can discover where the relevant data sources and algorithms happens to be. And the key is you need an intelligent engine that can actually coordinate all the calls to all the different data sources. And of course, in this context also, all the data happens to be each of the services receives and returns data in operable standards from W3C. Now, there was a brief comment at the very first talk of the conference about fair data. Okay, so fair data being findable, accessible, interoperable, and reusable. Now, fair data is essentially a set of principles, right? And there is no specific architecture or infrastructure designed or mandated by the fair data principles, right? However, Cedi is a precursor to the evolution of those principles. And the lead author on fair data, Mark Wilkinson, is a key proponent of having designed Cedi in the first place. So we are, in essence, this is a compliance issue, right? So Hydra is our query engine. It's a Sparkle engine for querying the registry of semantic web services, and it's a scalable version. The previous version that was academic had challenges, and we basically invested 4 years in scaling up this engine to a stage where it performs industrial scale. Okay, so so who are we really trying to support? Who are we really trying to help? The key is that a lot of the times the people who need access to knowledge are not the ones who know how to query for it, right? Your subject matter experts, your managers, they know what they want, but they can't get access to the data. And this happens both in large organizations and small organizations, all right? So we also want to support people, developers who are basically looking for a robust, cost-effective solution to integrate services, in essence, to solve big data problems. And I've got a little down here, ontologists too. We also care about helping the ontologists. Very briefly, this is so this is the query interface that you will typically see. I'll skip it then because I'll show you the demo then. What you're seeing here is where an agricultural consultant might sit down with a farmer and start using the query tool, where you're essentially just entering keywords, and it's basically pulling up fragments of an ontology and presenting these back to you. The whole point is that you, as an end user, get to confirm the intent of the query before it's actually executed. So here the query is about calculating the profit margin. You can then edit the graph, edit the ontology. So we now have, looking for varieties, we have of eggplants, we have a specific price per pound. We have a box yield and a profit per acre that we want to compute. Right? There's actually quite a sophisticated advanced cost model behind here with a whole range of different services. All right? So you're basically then here adding literal values. So this is something that really could be done strictly through a browser in any part of the world without having to have any data locally. So all data comes from distributed context. So here what we're showing you is a Sparkle query that you've just generated by building that graphical query. And it's just illustrating and so I guess it's already run once, but it's going to run again. And you'll see then all we get back very quickly is the profit margin and the variety. People don't need to know where the data is, how it's stored, right? And can have semantic query access directly to it. Now, we could go through this again, and then there's a different profit margin that can be computed. I'm going to skip forward in this context, but because primarily what I want to show you here now is essentially just the complexity of the cost model that's already been built and is called as services in the background. Now, through the query interface, you don't see any of this, but this is really, we've got all sorts of costs related to post-harvest cost, cash overheads, pre-planting costs, harvest costs, cost of different pesticides, etc. So this is just one of the capabilities that we provided. Okay. So if I return back to the slides, basically for a simple wrap-up, I guess pretty much what my key message is that integrated data is clearly a key asset. Don't make decisions on data integrated months ago. Make decisions on data that was integrated right now, late stage, just before just as you've requested it. Protect your reputation as a data provider and invest in your ability to integrate data seamlessly for real-time decision support and analytics. And I'm saying it's crucial and will pay dividends. Thank you for your time.